Hello everyone, myself Gokul. I am here to explain the physics behind the pasta. The first one is Calipari force. Here we theoretically and experimentally investigate the swelling and softening of pasta due to liquid inhibition as well as the elastic deformation and the adhesion of pasta due to Calipari force. As water diffuses into a pasta during cooking, it softens gradually from the outside inward as starch swells and relaxes. The softening follows three sequential regimes. Here the cooking pasta is classified into the three regimes as 1, 2 and 3. First regime is the hot glassy region in the pasta shows a slow decrease in modulus with the cooking time. The hot glassy region called regime 1 is now converted into rubbery transition region or leathery region, and it is called the regime 2, and it is very fast and becomes several orders of magnitude in elastic modules. The third one is the rubbery region that an asymptotic modulus about 4 orders of magnitude lower than the raw pasta. We find the modulus to be extremely sensitive to the amount of salt added to the boiling water. That the amount of salt added to the boiling water that can change the modulus of the pasta. Here is the three regime of the pastas. The next one is better cooked pasta with physics and a ruler. Multitudes of amateur chefs will soon enjoy perfect aldinate pasta and cleaner kitchen walls. Aldinate pasta means the ideal consistency of pasta when it's being cooked. The perfect aldinate pasta is quite firm to bite, not completely soft and slim. Simply, the aldinate pasta means it is the softening of the pasta which is not completely soft but quite firm to bite is called the aldinate pasta. Actually, the company named as Aldinate Pasta, which is located in US. As new research shows how measurements with a ruler, not the myothologized throwing against the nearest vertical surface, may be the best way to confirm when pasta is fully cooked. The measurement with a ruler is the best way to measure when pasta is fully cooked. In the presentation at the 2022 American Physical Society March meeting, science, aldinate, elastocalpitory and swelling of cooked pasta researchers from the University of Illinois Urbana-Champaign have utilized fundamental physical principles and conclusions using a ruler to measure the stiction distance between two vertically hanging pasta to gauge their cooking status. The researchers found by using ruler to measure the stiction distance between the two vertically hanging pasta. During a press briefing at 9 a.m. CDT on Monday, March 14, 2022, the researchers will discuss their results. The briefing will be held on-site and streamed via Zoom. The team observed how the noodles come together when lifted from a platter by a fork. This provided them with a grounding of how water-driven hygroscopic swelling affects pasta's texture. Now we can see how the noodles can come together when lifted from fork while eating. After cooking, the relative rate of noodles increases in width exceeded the rate of lengthening by a ratio of 3.5 to 1 until it reached the firm texture of aldinate before becoming uniformly soft and overcooked. That is, after cooked, the length and relative weight is increased, so the noodles come together while eating. As pasta is pulled from liquid, the liquid surface energy creates a meniscus that sticks noodles to one another, balancing the elastic resistance from bending the noodles and aided by adhesion energy from the surface tension of the liquid. The degree to which a noodle was cooked was directly related to the length of the portion that adhered to its neighbors. In the topic, what I have surprised means the addition of salt to the boiling water completely changes the cooking time. The researcher Tawfiq said, depending on how much the salt is added to the boiling water, the time to reach aldenate can be very different. The next one is how to break spaghetti cleanly into two. Spaghetti is the one of the pasta type. In 2005, scientists confirmed something pretty much everyone already knew. Dry spaghetti noodles never break cleanly into two. Instead, they fracture into three or more pieces, leaving little dry noodle bits all over the stove and the kitchen floor if you don't aim properly. Researchers at MIT have figured out how to snap spaghetti in two cleanly without creating any noodly scramble. It turns out the quest to understand the deep mysteries of spaghetti go way back. No less than Richard Feynman, the Nobel Prize winning physicist, put his noodle to the question. Spending an evening with a friend, snapping pasta trying to figure out what was going on. He never did solve the conundrum, but his efforts inspired researchers from France to dig into the tangled mess, which earned them a 2006 Nobel Prize. And here's the attempt of how to cleanly separate the spaghetti into two pieces. And here is the picture of noodles better defined. This is the picture how noodles or types of pasta can stick together. Hope all you can learn something new about my presentation.